I believe, ladies and gentlemen, we're ready to go. So, well, goodbye. Bye, Greg. Off you go. Get the hell out of here, will you? So, we're going to have a session, as you know, on Leos and Meos. We have a nice, diverse panel here of experts who are going to address some of the questions that, if I can get my brain in order, I'll actually work out how to ask them, or what to ask them. In the first instance, what I'm going to ask them to do is just spend a minute or so just introducing themselves and their positions in their company. So, John?
Susan, before you start, it's my great honor in the name of all the panelists here to first have you introduce as also one of the experts here. And I think also big applause to you joining us here as the moderator of this great session, Leo Meo, and I'm really happy that we have full house here. So welcome everyone. Susan, now the floor is yours.
Thank you, Kirsten, and I think I'd already taken the floor. So
Well, thank you, Susan. I'm John Phillips. I'm a general manager of Cobham Satcom based in California. So for those of you in the maritime industry, that's the former CTEL brand that we sell, so maritime tracking antennas. I'm very pleased to be here. I'm a relative newcomer to this industry. I've been with CTEL for 10 years, and prior to that, telecommunications with Northern Telecom up in Canada, and then came down to the San Francisco Bay Area for a couple of startups that we did DSL and things like that. So the satellite, relatively new, but happy to be here.
Can you use that one? Oh, sorry. You have to share a microphone.
Is it not? Okay, so, I'm Diederik Kelder. I'm the Chief Strategy Officer of LeoSat. LeoSat, can you hear me?
I can.
Okay. So LeoSat, we were here at the panel last year, so we introduced ourselves last year. So we are working on a LEO constellation in polar orbit in Ka band, and obviously I'm sure that there's enough opportunity to talk more about the company and how we see the market.
See if the song, yeah, it isn't.
Yeah.
All right, my name is Thomas from Newtec. I'm the CEO. Newtec, of course, being the ground segment designer and manufacturer in this room. We are very interested in the evolutions on Leo and Meo because we've traditionally been an expert on the physical side of things, bringing new standards, new enablers of space segment innovation to the ground. If we have people here trying to find billions of dollars of investments to push innovation in space, and we just want to make sure that all of that investment is going to be maximized in the applications on the ground. So that's what we're going to do.
Thank you, Thomas. Is this on? Or shall I just shout? No?
Shout.
How's that? Oh, look at that. So I'm Steve Collar. I'm the CEO at SES Network. So earlier this year, we founded two business units within SES. One entirely focused on video, which is called SES Video. Ooh. And one that's entirely focused on our data customers, and that's called SES Networks. That's what I'm the CEO of. And we brought together all of our kind of legacy data businesses, and that includes obviously O3B, all of SES's existing data customers, SES Telecom, all of our government business, all under one roof. And on Monday at the Paris show, we announced our next generation broadband system that we've called O3B Empower, and I'm sure we'll talk about that a little bit during the course of this conversation.
It was on. Yeah. Okay. So my name is Michel Forel. You hear me well?
No. Hold it to your mouth.
Okay. So this is better. So I am the director of engineering of the at Telesat. So Telesat is a Canadian company. We are located in Ottawa. So I have the pleasure to lead a very good team developing our next generation Leo system that we call it the Telesat Leo. So we'll be talking about this. Among other things, essentially my role is to essentially develop end-to-end satellite systems and develop innovative solutions to serve our customers.
Well, thank you, everybody. So I'm going to start one question each. Let me start with Michelle, furthest away.
Sure.
Just came in. So, Michelle, my understanding was that Telesat decided to invest in a LEO system, put a LEO system in place, basically because they see the GEO system basically dying. It will be gone soon enough, so you better stay with the curve.
Mm-hmm.
Is that the reason? And what convinced you that LEO was going to be the way forward?
So essentially, while we still perceive that the GEO systems will have an active play in the satellite industry, the LEO constellations, particularly the way we architect it, is a wonderful way to deliver high capacity at the economics that are needed in our industry. So by providing the clever implementation that is needed for this, we have realized over time that as we research on that this is effectively the right strategy for the future for Telesat.
How can you, I mean, most people's criticism, one of the big criticisms of LEO systems is how do they deliver the kind of bandwidth that they're claiming? They're saying OneWeb's going to have several terabits of capacity, but most of it is going to be serving the penguins down in Antarctica or the sharks somewhere out in the Pacific Ocean. How are you going to change that one?
So this is a very valid question. So in essence, if the LEO system is not designed properly, you can end up by having unused capacity over large regions of the world. Our approach is, and we have documented in our FCC filings and whatever we have done in public, is showing that we are using an approach where we can have both the usage of a global or polar orbit and an inclined orbit, combining the capacity and especially the ability to focus the capacity in the regions where the demand is more. But the main argument here is that we like to design the system to make sure that usable capacity is effectively targeted where the demand is, and as a result, we essentially design the satellites so that we can offer flexible beam steering, so with a large number of beams per satellite to address the capacity where the demand is.
Right, okay. So that brings me on to Steve. Obviously, O3b has steerable beams and a relatively small number of satellites in the MEO side of things. Do you believe that that is an expandable business case where you can focus your capacity, and do you get an advantage by being a MEO rather than a LEO?
So, look, I'm a big fan of any system that's looking to meaningfully change both the economics and the market share that satellite has in the broader ecosystem of sort of delivering networks and delivering telecommunications. Went hard about this. We're obviously the first broadband NGSO system to deploy. We've been up now since 2013, delivering services across the network, and so over that time I think we've learned a decent amount about what it takes to do that, what the economics look like and where you need to be, and we've put all of that sort of thought and learning into our next generation system, into O3b mPOWER that we talked about on Monday, and it's a dramatic scaling of the system that we have today. So exactly to your point, and we did this very thoughtfully, with the original O3b constellation, we have steerable beams that allow us to choose where we deliver our capability and our capacity match directly to the demand. The challenge with O3b in its current form is that we can't serve customers globally simultaneously. We can deliver services anywhere, but we can't deliver services everywhere. What O3b mPOWER does is it takes all of the benefits that we've got with O3b, the highest performance that's available, tons and tons of capability relative to anything else that can be delivered, and now we can deliver that anywhere. So if the customer needs anywhere from a megabit to tens of gigabits, whether you're talking about international connectivity or domestic connectivity, we can deliver that on O3B mPower, and we're super, super excited about it. I think it's truly game-changing, and that's an overused word in our industry and many, but I fundamentally believe that what we have with O3B mPower will meaningfully grow the market for satellite, which is ultimately, I think, in all of our interests.
So, will it be a trunking system similar to O3B? mPower will be a trunking system.
So I'd say two things. Firstly, O3B isn't a trunking system, and secondly, no, it will be, and exactly as I've just said, you can deliver anywhere from a megabit to tens of gigabits domestically or internationally across O3B mPower. So it doesn't look like any of the systems that are up there. You know, terminals from 30 centimeters to 4.5. This doesn't get sort of pigeonholed in one particular, in one particular vertical or sub-vertical. So whether it's an MNO, a telco, an enterprise, a cloud service provider, all in the fixed data space, or whether you're talking about a mobility application and delivering, relatively small amounts of data to huge amounts of data into a mobile platform, into a moving platform, we'll be able to do it with this system. And on top of that, it's dramatically scalable. So we'll launch about a terabit, a little bit more than a terabit to begin with, but we can scale that as the market grows, rather than launching a fixed amount of capacity into, and this is one of the challenges we see with LEOs, launching a fixed amount of capacity that by definition has to be more than you can possibly sell on day one. We can scale exactly as we have with O3B and start with the 7 satellites that we've already announced, and then grow to, a practically unlimited number. And it's, for that and a bunch of other reasons, we think it's sort of the most flexible, the most scalable, and the most and the system that can deliver the best economics.
Okay, so I've got to give you a little bit of career advice here, Steve. I mean, you seem to have taken on the habits of a CEO, potentially talking bullshit.
Is that career advice to continue, or career advice to stop? I'm not clear.
Well, I know ultimately you have to answer to your investors, so you've got to be a little bit careful about this. But I remember you just saying that O3B was launched with a lot of thought, and Greg announced O3B at the Com6 conference, and I remember what the antenna was going to be. It was going to be a $9,000 antenna. Now it's a $250,000 antenna because you never managed to hit the $9,000 side of it. So what I'm asking is
there a question?
Is this reality? Do you really think you can deliver on this? Have you really thought all these items through?
So the answer to that's absolutely yes, and I'm not going to speak to what Greg might have said back in 2007, right? But I will say that the cost of the terrestrial hardware for O3B has never been a big focus of mine. It's never been something. It's always been something that's concerned you, yes. Which I love the fact that you're concerned about O3B, but it's always concerned you more than me. And the reason it hasn't concerned me greatly is because, as a fraction of the amount of money that our customers spend on their network, the terminal is relatively small. If you're trying to serve a residential broadband market, the cost of the terminal is arguably the most important thing, because there's so many of them. The relative cost of that terminal to the spend across the whole network, the total cost of ownership, is very large. For our customers, it's rare that the investment in the terminal is more than the cost of 1 month's service. And for that reason, we now build that cost in. So we will spread that cost into, and we don't bill customers CapEx anymore. We charge entirely an OpEx model. And we'd be mad to do that if we were in any way concerned that the cost of the terminal was going to be an important contributor towards the overall service. So it's always been a topic that's been much more relevant to the traditional VSAT industry than it has been to the MNOs and telcos and, frankly, cruise customers or anyone else that we're trying to serve. Where you're exactly right is O3B is a system that's much, much better at delivering a ton of capability to a relatively small number of sites, relatively small number of customers, rather than a system that's able to distribute massive amounts of bandwidth to a large number of integrated networks, and that's what O3B and Power will do. And we've done. You can imagine we wouldn't be investing what we're investing without being 100% sure that we can deliver those into terminals that are appropriately priced for the service we're delivering.
Okay, so that's interesting, because then leads us on to Thomas. And Thomas, have they negotiated you down to $50 for a terminal now? Do you know?
That's the next session.
No, but it is a good point. I mean, when people think about MEOs and LEOs, the ground segment used to be more an afterthought than finding the bigger investment to get to launch or to get to the first stage. I think it's been a long time since 2007, so everybody got a little bit wiser. Well, there's still a potential pitfall on the ground segment for OneWeb and so on, that's clear. So, but everybody's involving ground segment manufacturers from the payload design now, instead of being an afterthought.
Do you? Okay, so from your perspective, you've got to handle a whole bunch of things, different frequencies, different speeds that those Leo and Meo systems, the Leo Meo systems are going to be flying over the head, right? So, is the technology already in place for that, or is this still a development program?
There is a lot of technology that's already been developed. Think about our venture into high throughput satellites. Obviously, we've got platforms, high throughput satellites doing 100 gigabits, so you get density and scalability in gateways already. Sure. You've got very high sized beams in terms of frequency. You've got 500 megahertz beams that we cater for these days. We've obviously have a large mobility development that was done, so that caters with things like Doppler speed, Doppler compensations, and handovers between beams. And so you've got mobility on one side where planes and boats move from beam to beam. So now you've got mobile satellites that you need to hand over and do things like that. So there's a large amount of groundwork that has been done to move to a next step, which is a big Leo constellation. Scalability in terms of speeds, I think we've been very wise in separating the baseband processing from the IP processing, so we can scale and we can have distributed architectures over multiple gateways. And of course, the number of gateways with LEOs typically tends to explode even. So I think we're pretty much done everything we need to do at this point in time in 2017 to take every single step between now and 2021, because that's obviously where most of it's happening.
But are we going to see a dramatic jump in terms of the speed at which you've got to flick between satellites? Because, and have you pulled in anything from the cellular business? Because I was talking to OneWeb about this, and they were saying that that's one of the reasons why they got Qualcomm involved, because Qualcomm, obviously the cellular guys are having to switch much faster.
No, I think our capability of switching and handover are coming from our continuous efforts on the mobility side. So we've gone from, traditionally you'd find ships that needed minutes to go from one beam to another beam, and now obviously we're on planes where it's about seconds, and that's moving to seamless. The whole effort there is to have no session interruptions and seamless handover between satellites, or it's actually, that's easier than seamless handover between gateways, to be honest. So our development on seamless handover is more coming from a mobility side than from the cellular side, to be honest.
Okay, and are you working specifically with any antenna manufacturers? We have one just sitting here right now. But
obviously, we're working with Cobham on a number of projects, but for the rest, we're not. We still have to evaluate most of the technologies on the phased array side, I must say, because that's going to play a big part in a number of applications that are.
But you don't have your own project for phased array.
No, and I think we're not going to have. We're definitely not going to start from scratch. I think there's too many activities already. There's been a lot of investments done. I believe we have a role to integrate the right technology into the ground segment platform, and that's going to be our role. Maybe even selecting some of the technologies for certain applications or for certain service providers.
So
we probably have a role in bringing the high speed and the high performance and keeping that into the flat panel array, because there's a lot of view on how to bring the cost down to the absolute minimum, but there's also verticals that require high speed.
Okay, so when are you going to acquire Kaimet? What's the plan?
I don't think we're going to acquire a Kaimet. So like I said, there's enough companies out there, and that we need to find a way to bring them into reality. That's what,
right.
And we're going to have a role in that.
I totally agree.
Yeah.
Yes, absolutely. Okay, Diedrich. Steve just said that basically he's going to bankrupt you before you've raised the money to actually get your system up, right? Are you screwed?
Well, I think in the whole discussion, I mean, there's a couple of general questions, and when people talk Leo, people treat all the Leo systems as if they are the same. So you have to allow me to go through a couple of technicalities to demonstrate to you that actually LeoSat is a different system and may have a completely different customer base than Steve is talking about.
Okay.
So I think that most of the Leo systems that you see today being developed have different characteristics, and with that different target markets. So they don't necessarily have to compete with each other or take business far away. They can be complementary. If you want me, I can focus on the LeoSat system. And we have, for instance, inter-satellite links. So it means that you have a whole different type of connectivity that you can bring to the market. Rather than going up from satellite to a gateway, we can do point-to-point connectivities without any touch point in between. Another technicality that we have is that we operate from 1,400 kilometers. So we actually had a higher LEO orbit, which is a sweet spot, which allows us to have global coverage with 78 satellites. So we're not a SpaceX, we're not a OneWeb, we're not talking about 1,000 satellites, we're talking about a limited number of satellites. Earlier question that you asked is like, are you satellites being idle? No, because all our satellites are actually nodes in our laser backbone in space. So they work. You said, are you going to sell to the penguins? Yes, we will, because we can actually provide direct connectivity from Antarctica back, for instance, to the US. So I think it makes sense to dive into a little bit more details and what actually determines each specific LEO system.
No, I agree, and I think it's a great opportunity for the penguins to move forward.
They're very happy. We haven't signed an MOU with them yet.
I know they can be a bit funny there. Yeah. But how many? My understanding was that LeoSat total connections you can get on LeoSat is 8,000 connections.
Yes, but I mean, our market is the high throughput market, so we do not. We do not. I mean, our minimum link for customers is in the range of 50 to 100 MB. So we're not catering to the broadband access market. It's a very specific market that we're targeting.
Right.
It's the enterprise market.
Enterprise market, or just the financial market, the one lower latency?
Well, again, I mean, there's several attributes that you get if you have a LeoSat type of constellation. For instance, one of the things that you're alluding to, the financial industry, is yes, we have low latency, and because light travels faster in vacuum than in fiber, in glass, there is a tipping point where actually on the longer distances, LeoSat is faster than fiber. Which, I mean, for us, I mean, being satellite people, it's great news. I mean, because we can now do something better than fiber, or better than the terrestrial system, which is, it's a wonderful opportunity because it's a grow the pie thing. It's like we're not fighting for the same customer segment. We are actually, and that's what we've seen in interacting with our potential customers. We've seen customers coming to us. I mean, okay, I've been in the industry for 20 years, who would previously not go to the satellite industry for certain solutions. And that's, I think, the beauty of innovation. And actually, as a satellite industry, it's a good thing that we develop a technology where we can beyond our existing customer base.
Right, but as you're talking there, I'm thinking, actually, you should be the CEO of LeoSat.
And then you could talk more bullshit.
Well, I think there's a bit of that.
Plenty of career advice.
It's one of the qualifications. Because, some of this stuff I really agree with, what you're saying. I really agree with. And we as Comsys have had some fiber companies come to us and ask us to do technical calculations on what their service will look like versus your service in terms of latency, and see whether you would win over them, because they're nervous a little bit. So I think there is a positive to that. There is a positive. There are some people that are concerned about it. But on the other hand, equally, I think you definitely will have some customers which will love your system, but I'm not sure you can get beyond those real niche customers. Now, if you can get them to pay enough, then to make your system economically justifiable, it could work. But I'm not sure you can spread way beyond that. So I'd like to understand, what would you bring to other enterprises other than the financial guy who 1 millisecond of latency saved?
Right, and I didn't want to be too long.
200,000 a month.
I didn't want to be too long in my answer, so
No.
I focused on the latency, because that's the issue that you brought up. So
Yeah.
what we see, what customers, when they look at the LeoSat system, there's several unique attributes. I mean, the lowest latency on certain long-haul routes, but there's also the security concept. Because we have inter-satellite links, you can go from one place on the Earth to any other place on Earth without touching any gateway, whatever, on ground. We have ubiquity, we have coverage in the Arctics, in the north and the south, so we have a full global coverage. So what we see is that customers, when they come to us, and some of them indeed, they trigger maybe on latency. If you see in the last 5-6 years, if you take the total internet traffic, the amount of private network traffic, VPN traffic, has, I don't know, tripled or quadrupled. I mean, you can see it's now like 70% of the total internet traffic is VPN traffic. People are concerned about security, and your security over VPN is as strong as your encryption. And by the way, you still go through other people's gateways. So people who are concerned about security, they are seriously looking at LeoSat, because you actually provide security at level 1. And sometimes people need a combination of that. So it's a combination of factors, and that attracts people to LeoSat.
Okay, now that's very interesting, and I like to hear the fact that as satellite we can bring something more unique to the telecoms market.
I hope my response didn't disqualify me from CEO.
Yeah, maybe not enough bullshit in it. So next question is, where will antennas come in? Are you going to need flat panel antennas?
Yes. Yes. And actually, I mean, obviously, we stepped into this game much later than O3B, but I mean, we're standing on the shoulders of O3. I mean, O3B has done a tremendous job in preparing the market for non-geo systems, and so we will benefit from that. And the whole ecosystem will benefit from it, because these antennas are being developed. So for us, it's just a matter of looking at what the right system would fit our customer needs, and that can be in terms of throughput, what people want. So in that sense, I'm very optimistic about the ground segment that's available by the time we will launch.
Okay, good. And that, of course, brings us through to John. Is this another bankruptcy question, John? Cobham about to go bankrupt because all these flat panel antennas are going to come out, and I don't know of any particular development at Cobham. I mean,
Okay.
You want us to just stand on a ship pointing the antenna all the time, or what?
So let me start first with how we're entering the LEO game. We've taken our ship-based antennas, which are great pointing and tracking antennas, and placed them terrestrially. And we haven't done this recently. People have been using our maritime antennas in radomes as trackers for weather satellites and for Earth observations for decades. So that's been our entry point, because it's predictable and our stuff works, and it's actually a slight change on some of the traditional trackers. So in that regard, we think entry to the market is quite safe, and we're working, say with Telesat, we've got a 3.7 meter Ka tracker up there right now, and use that to command and control the first 2 prototype satellites. So that's an entry strategy that I can sell to the big bosses at Cobham, and it makes sense to them. Now to the big question, right? Flat panels. Cobham's been doing flat panels for years and years also. Aeronautically with L-band, we're designed into a lot of airframes. That's L-band, right? You You jump to KU and KA, the Chimera guys, they started at KA. Ambitious, right? Terribly ambitious. They showed us receive panels that was separate from transmit panels. They were okay. They changed gears and said, hey, let's look at KU. That's good. I think the Leo constellations are actually a good thing for the flat panel guys because it gets us away from this huge debate about gain. I'm a parabolic guy, and I know that that antenna is really efficient, and I get the dB gain that I need out of that thing. When you're lower orbit, maybe you won't need as much. Obviously, you don't need as much. Is that going to give the flat panel guys something to work on? We're a long way from them taking over the market. And I think the service providers here, the guys who are targeting service provider, they are going to start with the higher end services. For those that tracking parabolic is fine. As Steve says, he's going to build that into the cost of the service, and the end customer is going to pay for it. They just won't know it. It'll be amortized over. So.
Well, okay, and then this is another CEO thing. I'm not sure I agree with you. And the reason I don't agree with you is because I think, number one, the flat panels, I don't think Leos, quite honestly, are just going to survive on their own. I think they're going to have to be twinned or paired with, all the systems are going to have to come together in a single type of situation. And that will mean flat panels will have to switch between GEOs, LEOs, MEOs.
Not necessarily, especially with these inter-satellite links, you can go satellite to satellite in your constellation, but also satellite up to HTS, a GEO.
No, because if you went up to the LEO, then you're going to use capacity on the LEO, and that doesn't give you any advantage by going to the GEO. What's the advantage? Just, okay, you can reach further, but that's it.
Yeah,
the issue is going to be on the LEOs. The issue is going to be, more than anything else, just how much bandwidth they can deliver on stuff. Now, okay, in Steve's case, and this wasn't one of his CEO comments, that he can deliver the right capacity in the right place. And in Diedrich's situation, he's talking about, I can shift capacity around my system via intersatellite links. But in OneWeb's case, they don't have that at all. So they may have terabits of capacity, but they can only put apparently it's 200 gigs over North America, is what they'll have.
But this is going to scare you. I actually agree with everything you just said, Susan, and it's not just about the different systems, it's that we need to get ourselves away from thinking about satellite networks and thinking about just deploying networks for customers. And that means a lot more intelligence on the ground.
Yes.
It means a lot more, use of SD-WAN and similar kinds of technologies to route intelligently across multiple networks. And, kind of that's how we're thinking about mPOWER. That's why we're excited about all these other different systems launching, because when we get to a point where we're thinking about satellite as part of a bigger network to deploy to MNOs or telcos or whatever, then it becomes, and the trick is moving us from sort of niche and scarce and expensive to scalable, affordable, and plentiful. And once we get to that point, we then become sort of a choice of first resort rather than a choice of last resort. And it's where we're all trying to get to, and I think each of the systems has merits. Certainly from our standpoint, we can see a very clear path, and we don't think GEO is dead, by the way.
No.
We see GEO as being a very, very important part of future architectures which are flexible and go across GEO infrastructure, medium Earth orbit infrastructure, LEO if it exists, and terrestrial.
No, I very good, Steve. I'm gonna downgrade you to COO
Maybe.
now. No, actually, giving us some reality in there, and I totally agree with you. Sorry, you wanted to.
Yeah,
Michelle?
just wanted to add a comment that further to what Steve mentioned. One of the critical elements with these next generation satellite networks is that we need to change the way we integrate with terrestrial networks. It has to be seamless, easy to deploy, easy to commission. Even if we use reflector-based systems, we'll need to make sure that these are easy to deploy, But ultimately, if flat panel technology reaches the point of the cost points and the performance that we expect, then yes, they could also contribute to make that seamless integration to terrestrial network. But that's fundamental in the change of the way we need to design those systems.
Yeah, and I totally agree with you, and I think these are interesting things. So I wanted to finish off with John. I'll come back to you in a second. Hold on, John, because while we're on this subject, I then want to bring that through to Thomas, because a couple of very good friends of mine who are been in the VSAT business and have made millions, done really well, are now getting the hell out of there. And when I say, why are you getting out there? It's going to be finished. For the VSAT operator side of us, it's going to be finished. And one of the reasons they think it may be finished is because ultimately a VSAT is going to be like a smartphone. You're not going to have to sit there and configure it and make sure everything's right. You're literally just going to switch it on and it's going to work. And it's going to configure everything. And applications are going to understand where they're going to go. Some of the things Steve was saying about SD-WAN and things like that, decision of where everything goes. Do you see that kind of technology being brought into the Newtec platform, so it just makes things easier to deploy and quicker?
Well, yeah, absolutely, and that's what we want to do, and to a certain extent it's closer to our heart than to some other vendors. I mean, you can deploy a VSAT system in a way that you're going to go all the way as a vendor. I think some of our competitors are not only deploy the system itself, they're going to go do things on the next layers, and they're going to go specialize in fancy NMSs, and going to go further into deep packet inspection in layer 7, and they're going to do everything on the VSAT system itself. While what we're saying here is that the network itself is the dominant factor, and we just have to figure out the best technology to plug into a network, and not necessarily pretend like we're alone in the world and that we have to provide every single feature until the accounting and billing and stuff like that. So for Newtec, it's a good thing, to be honest. We can focus on our core added value, which is making sure that the whole network works as optimal as possible, as easy as possible. We spend an awful lot of time trying to make things easy to deploy. We did make the necessary apps for installers to point and play and do that with their Android or their Apple phone.
I actually did it in my own house with one of your antennas.
So we've got all that, but I mean, bring it back to the basic thing, being very performant, plugging into a network, and not pretending like we're all alone on the planet. That fits well with Newtec.
Do you also see the idea that if you had, and I hate calling them flat panel antennas, because I think that's just too simplification, and it's not going to be that. It's actually going to be, I call them Kespers, because they're conformable, electronically steerable, phased array antennas. They are much more complex than just... I can run the...
So we might use
I can't
that
say that without spitting, so...
If you didn't trademark it, we could use it.
So, because it is complex, it's a very complex thing to get right. So those antennas, I think, are going to have to switch between LEOs, GEOs, MEOs, and choose, and maybe even perhaps choose which way to go. You within the modem part end of it, you're going to have to be with that and even driving it.
Yeah, I think, well, that part is probably the easy part, because obviously we have a decision engine centrally in our platforms that have, well, first of all, we have initial beam acquisition, which is basically the intelligence on the terminal side to decide what to do first to get into the network. It could be linking up to GEO, it could be linking up to LEO. In our case, it's linking up to wideband or linking up to HTS, and then certain beam choices. So that's initial beam acquisition. It exists for nomadic terminals, it exists for fast moving terminals, so that's fine. And then we've brought all the intelligence of switching into a centralized place where feedback from the market said you have to make it central, you have to have business intelligence from the service providers steer that choice. Are you going to go to LEO? Are you going to go to GEO? In our case, it's are you going to use the wideband? Are you going to use this beam, that beam? What's the cost of those beams? What's the lowest cost route? What's the load balance of your network? All of these things.
What latency do you need?
Yes. So it exists. That's not the most complicated
you're already on
thing.
that path.
It exists.
Okay,
today.
that's
So it's
interesting.
the
in itself.
external mobility management. It exists for maritime, for aero, and whether it's a LEO or a GEO that needs the choice, that's not the difficulty. The difficulty is having the right antenna to do it. That's definitely. But once the antenna is there, the choice of switching is an easy one. You can script
So
it.
now this brings us back to the dinosaur who's sitting next to me, John. Are you listening to this and thinking, oh my God, Cobham's a dinosaur? Because you're talking about an antenna. You're going to need something which is conformable, electronically steerable. Panel. What are you doing in that sense, other than the fact, oh yeah, we provide these nice little parabolic antennas, I'm a parabolic person, I can point it anywhere.
No, we're also tracking the progress of more of the companies than just Metal. Right? There are some other startups out there that have some compelling technology.
Yes.
In-house, we've got Cobham Technical Services in London who are also working on things, but we're not there yet. Nobody in the industry is there yet. So, it's not going to happen overnight. We're working on different technologies, but right now, parabolics are what all of these fellows are going to use.
Well, they
And
don't
we're
have
there.
a choice right now.
Yeah.
No, but we'll be using them for a long time.
Right.
We absolutely will be using them for a long time.
Yeah.
Flat panel's not the panacea. Flat panel will be a part of the market for O3B and Power and for SES and for others, but then it's not. You won't find every application for every customer will go flat panel. I'm 100% convinced of that. And actually, a little bit where Thomas was going, I think the trick for our customer edge terminals, which is what we're calling them, isn't so much RF, which is kind of what we get obsessed about, but it's more so our future terminals will have edge compute, they'll have storage, they'll have application support, they'll enable SD-WAN, there'll be intelligence built into the terminal. And the reason this stuff's all important is because, a little to what DK was saying, any place we have an advantage over terrestrial networks is a great thing, and we have the ability to push edge compute and edge storage much further into the network than any other technology that's not satellite based. And that's super exciting. And that means that if you think about the challenges that some of the MNOs face in rolling out network beyond the kind of major metros, as they get further out, it gets incrementally more expensive. It doesn't for us, right? It's the same cost for us to deploy in the center of town as it is, in a village, in principle. And so that means we have a compelling proposition. We have a unique space as part of an overall mobile network infrastructure, and we need to, again, to me, our capabilities need to reflect much more closely those of the terrestrial world, the terrestrial industry, and the mobile industry, and so the RF challenge, which is very much the satellite challenge, is a piece, but it's not the biggest piece in my mind, and we've got to have the kind of capabilities in our ground terminals that look very, very different from, I would say, VSATs of today.
I totally agree with all of that. So, John, just to finish off on your side, realistically, as you're looking at the flat panel side of things, I think flat panels are coming and will exist and all that kind of stuff. My biggest concern is, can they be delivered at a price point which will make it economically viable?
Yeah, exactly.
For which market?
Well, for all markets, ultimately, we need to be able to get antennas down, I think, to hundreds of dollar type level for a flat panel Kessler.
For which market?
For every market. Ultimately, if we were dropping them on a cellular tower or somebody's house or a bank or a ship or an aircraft, they'll pay
Aircraft will
50,000, 100,000, yeah.
And if you're dropping them on a cellular tower, well, that cellular tower might be a macro cell going up to a LEO or MEO or GEO.
Yeah.
And then locally, it's providing base station capabilities for the local population.
Right.
So those local population folks don't have a flat panel terminal in their hands. They're going to repeater cells. So the flat panels, I believe, will come in as fairly high-end performance devices that you need it flat because of your application. whether you're...
Well, I kind of disagree with that. I think that for any big cell tower which needs a lot of data, then ultimately fibre will win. Has to.
Well,
Because
unless you're in the middle of nowhere, but yeah.
Well, yeah, but there's plenty of places that are in the middle of nowhere which have exactly this. They run them out. If it's happened in Brazil, initially they rolled out a whole bunch of SCPC links to a whole bunch of places where the telcos were saying, no way is this ever going to, okay, because we have a USO obligation, we've got to do this. Once they rolled them out, I think they rolled out something like 350 sites between all the cellular operators. Now, how many are left SCPC? About 150, because 200 of them, they said, oh, it's worthwhile, stick a fibre there.
But I think you're talking about, so the world of satellite even 3 years ago in terms of the technology that was available versus the world of satellite in 3 years, the difference between those two is dramatic. And I think if it's not the case, well, it's dramatic. And I think the number of places where satellite can be very, very relevant in mobile environments and in telco environments is massively growing, not massively shrinking. You're on a massively shrinking path, and I'm 100%. And to be honest, you know, we launched O3B in 2007. You know, we had the idea in 2007. We launched it in 2013-14. There were 3 billion not connected to broadband. There are now 3.9. Based on the UN survey that came out two days ago. So this problem isn't shrinking, it's growing, which means this market isn't shrinking, it's growing. If we think for a single second that isn't going to be the case in 3 years, 5 years, 7 years, or 10 years, we're deluded. And we've got great technology and great opportunity to be a fundamental part of this market, this much bigger market than satellite
Steve,
has ever been. No, hang on a second. Sorry, we tend to want to sort of assume that the answer for the fibre guys is easy. It's really not. It's really hard to go build fibre networks in the places that we're talking about and do it affordably, which is exactly why it's not happening.
Okay, I agree.
Yes,
Diedrich, you can.
Yeah, because you said that, you know, as soon as fibre arrives, you know, as a satellite operator, you're out of business because they will always win. With all respect, I find it a little bit of an outdated statement because, you know, a system like LeoSat has attributes that can compete with fibre and actually can do things that fibre can't do. So even if fibre arrives, we can still do things that fibre cannot do. And LeoSat.
And an example being
LeoSat is not a gap filler. And that's what I'm trying to say.
Sorry, well, if fibre arrives, what are you going to do?
That's the broadband access market. The broadband access market is, you know, it's like in places where there's no broadband available. That's where. So then obviously when fibre arrives or a terrestrial solution arrives, usually that's cheaper and that will win. But take the case for a lot of satellite applications. I mean, some of the applications Steve was talking about, mobility and ships. I mean, fibre will not be able to ship.
No. I totally agree.
In the LeoSat case, like the examples that I mentioned, which is specific low latency on the long distance, specific security aspect, is that's where we can beat fibre. And
okay, I want to.
So what I want to ingrain here is like LeoSat is not a great gap filler. That's not our business strategy.
Yeah.
Sorry.
Listen, I want to hear the positive. I want to know that satellite and VSAT is going to have a role to play in the future. I believe that if we bring the technologies together at the right time and the right price and the right efficiency, yes, we can beat terrestrial. Now I'm listening to all the things you're saying, but I'm trying to push you to the edge just to understand whether this is real and whether we can achieve it. So, Michel.
Yeah. So I wanted to add that along the lines that we just talked about, that today's technology that we're reviewing to implement on our Telesat Leo constellation is really a game changer to reduce or change the economics. So the reason the telcos are looking into fiber to replace satellite technology is that because they find it's expensive now and it's awkward to connect to our satellite networks. By making it simple to connect and to have the telescope to order a circuit from Telesat Leo, as simple as ordering a circuit from any other telcos, we can change the game dramatically and prevent that they go for other techniques.
So what kind of price per megabit do you think you can bring it down to?
I'm not allowed to talk about that.
No, of course not. Well, no, because your CEO's not here. He's not here to bullshit us. The fact of the matter is that, and I quote this to many people, back in 2012, into Africa, before we had fibre in Africa, we were paying $3,000 per megabit per second into Africa. Today, the price is $3.50 per megabit per second to land in Africa on fibre. And I read something the other day saying, gosh, that's so expensive. It's 10 times more than you would pay per megabit per second across the Atlantic. That's one question I have. How do we hit that target? How do we put competition on those guys at those kind of levels?
Okay, that's a question for the other guys to answer. But let me first comment back on. I'm quite optimistic about the whole 4G LTE thing over satellite, and you mentioned Brazil specifically, and you know that we've been deploying a lot of macro cells in Brazil over satellite lately, and they've pushed their speeds up to 50 megabit returns and things like that over satellite, and they've moved from C-band to KU band first, yeah, and the Brazilians are launching a full satellite only for cellular backhaul in KA band. What? Star 1 D1 is a full satellite for cellular backhaul in KA band. So the optimism because you mentioned Brazil specifically on the macro cells, the optimism on satellite is quite big there. They've moved from C to KU, they're moving from KU to KA. We've enabled the usage of these higher bands by bringing them high availability for high bands. And they're launching very big macro cells, and then they'll even launch a full satellite. So I think there is some optimism in the growth of LTE, and maybe later on 5G we'll see, but over satellite, it's not done yet.
Okay, no, I agree, it's not done yet. But so, did anyone else have a comment on all that? Are we going to hit the price points we need to hit? Are we going to find ourselves competitive enough?
Maybe I'll just add that from an engineering perspective, I'm not the CEO, but all evidence are that we can hit very competitive price points. And that's all I can say. And this is due to the technology that we bring on the satellites, the usage of active arrays on the satellites, processing inter-satellite links, bringing flexibility, and especially having the ability to focus, as Steve mentioned, focus the capacity where the demand is. And to maximize the usability of I think the words you've been using, productivity of the constellation.
So I then need to ask you, Steve, what price point do you think you should
So look, a good reference here isn't what we think around this panel, it's what do we observe the behavior is of our customers. And if you take the cloud service providers, which are, we like to think that Google and Amazon and Facebook are the companies that lead us in everything, right? Apple have just announced a new phone and everybody wants, so we take these guys as a reference. So let's observe their behavior in terms of what they're doing in connectivity and in access. So the first thing to say is, they've all said, and consistently, and pretty vocally, that it's a fundamental part of what they want to do in the future is connect more people. You can speculate as to the reasons, but all of them, and the CEOs of the highest value companies in the world today have all said it's either my personal or it's my company's mission to bring connectivity to the world. And none of them have found the right answer yet. They've all tried fiber, they've tried drones, they've tried balloons, they've tried a whole bunch of different access technologies, and they haven't found an answer that gives them the ability to go connect the 7 billion people on the planet. And all of them, I think it's fair to say, believe that satellite is a fundamental part of their future access ecosystem. And I find that pretty exciting, right? So that's not to say that satellite will connect 7 billion people. And it doesn't have to. What we have to do is be an integral part of the network and an integral part of the systems that are built to connect the planet. And I absolutely believe that we are nowhere close to where we can be because we've always wanted to keep satellite scarce, niche and expensive. You mentioned it being a bad thing that we've gone from 4,000 megahertz to pick a number, right? I think it's a fantastically good thing because what we've done at the same time is gone from, you know, a relatively trivial amount of data delivered over satellite, and I'm completely obsessed with data, to a lot more, right? And in the future, whether all of these systems get launched or some of them or just ours, will be a much, much bigger part of that ecosystem. And you have to be relevant. In data, you have to have scale, you have to bring enough bandwidth to be relevant, you have to bring a performance which is interesting, which is all about latency, and you have to be able to deliver the economics to close business cases for your customers. And if you can do those four things, we can be dramatically successful. And we can create and be part of a market which is orders of magnitude bigger than the one that we're part of today. So I'm a massive believer in abundance rather than scarcity. I think the fact that we haven't seen those sorts of levels before is because we've never had systems that have been designed to be a part of a proper network, a proper ecosystem. We've always been niche and scarce and sort of been obsessed with high price rather than let's make our technology much, much more applicable to the much bigger market that's out there.
But Steve, I've just got to say here that I don't think you can blame the VSAT side of
I'm
the
not
business.
blaming anyone.
No, I am. I don't think you can blame the VSAT or the data side. I think it's your bosses and the heading up Eutelsat and heading up SES, and all you guys have been so focused on making tons of money in the video business that you're like, why would we have to take any risk?
I totally agree, which is not to say I agree with that it's all my boss's fault. What I agree with is I think where satellite has come from and where it's focused for the large part over the last 20 years has been broadcast, right? Yeah. That's been, and data, whether you think about data delivered to government, whether you think about kind of broadband, whether you think about other kind of, or mobility for that matter, has been a little bit of an afterthought. So within SES, it's certainly not an afterthought, but 2/3 of SES's business is video. And so naturally, when the investors are thinking about, investing in SES, when the SES board is thinking about its investments decisions in the past, the focus has been naturally much more on video than it has on data. And the challenge is to put up a satellite-based data network takes a significant investment. And I give SES massive credit for the decision that they took in 2009 to invest in O3D, to continue to invest in the business, to watch us sort of become the fastest growing satellite operator of all time, to develop the business now to the point where we could go and invest a significant amount of money in O3D and power, the sort of money that satellite companies have traditionally only invested in DTH neighborhoods, and allow us to become a very important part of a future data network. And I think that's equally true. If that happens for some of these other guys, I'd be super excited about it because I think it will build a much, much bigger market for the satellite industry.
Okay, now most of that I agree with. I do think that the SESs and the Eutelsats and the big buyers of satellites in this world have suppressed the development that should have happened, and they did. No, you can't reply to this.
But suppressed is the wrong word. I think
they just built bigger satellites, but the same thing, not more sophisticated satellites. It wasn't SES that came up with the idea of O3B. They would never have come up with that. And there's plenty of people who are sitting there saying, no, we're not going to do this, we're not going to do that. No, we need innovation in this market. We're starting late into it, is my view. So, Thomas?
Yeah.
What do you think about the spacecraft side of the business?
Well, let me first confirm that from an investor point of view, this obsession with broadcast, of course, Newtec, 40% of what we do is media, so I can't complain. But just prior to this little gathering, there was an investor at our booth, and he wanted to talk to us, and said, fine. And I had all this idea of how exciting what we are doing with Newtec. And the first question he asked was, how many DVB-S transponders do you think are going to migrate to DVB-S2? That was the question he asked, because it's so relevant for SES and Eutelsat in terms of pricing of transponders. So it's annoying, that
Yeah.
part, to be honest. So, but innovation in space, yeah, there is, well, it's coming. I mean, we're sitting here around the table with more innovation on spacecraft than ever before. It's even that much disruptive that there's many satellite operators that cannot make a decision at their payload manufacturers today because they're not sure that choosing disruptive technology, whether it's Leo Meo or next generation HTS with beam shaping, switching, and
Yeah.
beam hopping, and the flexibility of some of what you were looking for, it's become a very difficult choice, and it's becoming a very in an investment choice with a great amount of risk, which in the past was just, okay, let's buy payload for places that we need DTH environments or where we have gaps to fill. So innovation in space, it's definitely coming, not only on the Leo and the Meo, but also on the HTS 2.0, as we would call it. And it's hugely disruptive to the extent that indeed you got to get the ground segment involved, otherwise you don't know where you're going to get.
Well, I must admit, I've got to say that I get a little bit nervous that Kirsten's going to give me a slap after this, because she said, we're supposed to say at Leo Meo, and now you ended up talking about geos. You're not going to get upset with me, are you? Okay, you better wave and shout at me when we're running out of time, because we can go on
I have
this
time.
for a long time. Diedrich,
Yes, I'd like to talk about this innovation aspect. Is that in that sense, actually, the history of Leosat is quite telling. Is that Leosat was founded by two persons, Cliff Anderson, Phil Marlar, who actually did not come from the satellite industry. So they worked actually in the cruise line and the oil and gas business, and were looking for a satellite solution that they couldn't get in the market, and that's what triggered the whole foundation of Leosat. So, I mean, I myself, I've worked in the satellite industry for 20 years. I've worked for fairly large companies. And that's what's exciting about Leosat. Sometimes you need outsiders to do things. It's not always that the incumbents are the ones who innovate and have the ability to innovate for many reasons. I mean, we can talk about this for hours if we want to. So
we've got to see. Yeah, we've got to see the wider.
I saw this happening. I saw this initiative, from people outside of the industry, and I joined the Leosat initiative because I believe it. I think Leosat is answering a customer need. It comes from the outside, and luckily we are from the outside now innovating the satellite industry and hopefully growing the company. And, we will all benefit from it.
Okay. No, I agree, and I think we have to look at the wider picture, as Steve and Thomas described. And now, Michelle, you're going
I
to
just
give us
wanted
the wider
to
picture
comment
as well?
on in terms of innovation. While we all think, or we all see that there's a requirement to bring innovation on the satellite, and this is happening, but this cannot be made in isolation of the rest of the system. We've talked about intelligent terminals, easy to deploy, but all that has to work together. So the only answer really to this complex problem of developing an optimized LEO constellation is to design that from the ground up and have the players like Newtec and the other vendors to participate in the overall system design. So innovation is from one end to the other completely.
Yes, interesting. So, I don't know how much time do we have left? Kirsten?
5 minutes.
5 minutes. Is there we've kind of gone round and round this. Anybody in the audience has any questions that you might consider interesting?
Hi.
Yeah.
Hello, my name is Hubert Burns. I work with Magnitude Space. We're one of these new space kids that building a satellite IoT network based on nanosats. When I listen here, and the word dinosaur came up, but I see only the focus on these high market segments, these very high capabilities, these shrinking services. I would like to ask Panel, what do you think of a little trend we have in the internet, like IoT? What do you think about that? Have you a solution for that?
Well, I'll give you my view, but I think we'll get the experts in first.
Well, let me first congratulate you with your MOU that you signed with Iridium. No, I mean, obviously, IoT, it's very low data rate. So, necessarily when we build these big LEO systems, we have to focus on high throughput because you need high volume and to generate enough revenue.
I don't agree.
if you target that specific market. So I know a little bit about
We talk
your
about
initiative,
innovation.
and
You're targeting, again, the same old markets. Only the broadcast is gone, now we look for the next big data market.
no, but I mean,
So
it would
what's
be
new?
wonderful if people like you are sitting on this table and can join the discussion.
Yeah, maybe
because
next year.
Okay.
You address a specific part of the market,
Right.
and
We
it's a
got it.
very valuable part of it.
We've got to go straight to this. So, Michelle, what
Yeah,
what do you?
so I think that IoT connectivity to the satellite is a good thing at L-band. For instance, it's efficient because small terminals can be. The way we see that IoT with respect to the Telesat Leo constellation is that we think this will generate more traffic simply on the networks that will require more capacity in general. So ultimately having connectivity from Leo to serve the telcos and the other service providers will assist deploying IoT. But connecting K-band into small devices at low data rate or even intermittent data rate is we believe this is not as efficient use of the capacity directly. I mean,
I agree.
but indirectly there's a benefit definitely.
There's more than only KB.
If I can answer that a bit, I mean, the Earth observation applications are very diverse, and I think they're going to add to the ecosystem in terms of equipment adapting to be able to handle it. That it won't operate at KA, that's a given, but the ability to land your traffic and track your satellites is something that vendors like us are very interested in, and we're participating in. So, yeah, I think it's a big component of
We
this.
use your antenna.
I think there are many people who believe that ultimately it's cellular is going to take over the IoT market.
Yeah.
Only covers 10% of the world. Huh?
Yeah. But that's a good point. Cellular is a good example. For cellular, we make base stations. The base stations are connected through any means we can over satellite. And you could imagine that for IoT, we're going to have base stations as well. Not necessarily going to connect every device directly to satellite, but in large rural areas and you can and other areas, you can imagine that base stations that collect IoT data with IoT protocols will be linked to the Leos and the Meos of this world. That makes a lot of sense. It's the same way we do for cellular.
Totally agree. So in summary, because I think we should shut it down now, in summary, what it comes down to is we, in the VSAT and satellite industry, have a lot of challenges in front of us that we have to deliver these on time, on budget, and with the right solutions. But if we do that, potentially, we could become the global sun for the world, light up the world, potentially. And thank you to all.
I want to go and tackle the
Yeah,
Thank you.
Thank you. Yeah, we'll miss the weekend, so I'm going to go home. Is that right?
Hello, Steve. Of course I do. How are you? I've been, Dave been on Thursday at the radio with Leo. Oh, okay.
Did it go well? Which one? You did the last one. Yeah, good.
Just one thing. Thank you very much.
Well, thank you.
I did.